Math 1342, Section 1.2, Sampling from a Population. Video 1, Review of Material from August 23rd, 2021. Normally, the material in this video and the following videos is what we would have covered on Wednesday, August 25th, 2021, had class met that evening. But for the reasons explained in the announcement that I posted to Canvas, class did not meet. So I'm going to post a series of short videos covering the material that reviewing the material from 1.2, covering the material we haven't finished from 1.2, and going through section from 1.3. Hopefully each of these videos will be relatively short on their own, and hopefully there won't be too many in a row to watch. So for the first video, I would like to just quickly review the material that we discussed on the first day of class on August 23rd, 2021. And to do that, I'm going to share a PDF that is from the second edition of the textbook that we use. Even though we are using the third edition, I've checked section 1.2 from the second edition, and it's pretty much the same. However, when I do give the homework assignment, it will refer to page numbers and section and the homework question numbers from the third edition of the textbook that we're using. All right, to quickly review the material that we discussed last time, I'm just going to go through some of these, some of the pages here. We discussed, of course, samples and populations. A population is basically all individuals or objects of interest, whereas a sample is a subset of a population. So for example, if we wanted to study all students at UT Tyler, that would be considered a population. But if we wanted to make an estimation about something for that population, we might take a sample of 100 students that we find in the student union or something like that. Statistical inference is the process of using data from a sample to gain information about the population. And the main reason for statistical inferences is sometimes a population is too large or too dynamic, meaning that it's always in a state of change, to measure accurately. As a consequence, we take a snapshot of the population by selecting a sample from it that we can measure quickly and accurately, and then using some statistical inferences to glean information about the population. By the end of the semester, you'll know that those two processes are a confidence interval to estimate a value for a population and a hypothesis test to test a previously existing claim about a population value. It's kind of a cycle where we have this population from which we collect data. That data is the sample, and from that sample, we make a statistical inference about the population, and so on and so on. We also discuss sampling bias. And although I'm not going to go through this particular example, sampling bias occurs when the method of selecting a sample causes the sample to differ from the population in some relevant way. If sampling bias exists, then we can't trust the generalizations from the sample to the population. Unfortunately, sampling bias is very difficult to overcome, but the one reliable way to do that is to use what's called a simple random sample. We did go over the definition of a simple random sample. A simple random sample of n units. Remember, a unit is a single member of a population. But a simple random sample of n units, when you're choosing one, then all groups of that size in the population have the same chance of becoming the sample. This is equivalent to saying that each unit of the population has an equal chance of being selected, because the value of n, the size of your sample, could be a sample size of 1. Taking a simple random sample does avoid sampling bias. The problem, though, is it's difficult to choose a simple random sample. Although it doesn't say it in this textbook, I believe that on class, I told you that the random and random sample means that every element of the population has a chance of being selected, whereas simple random sample means that not only does every member of the population have a chance of being selected, but they have the same chance of being selected. So choosing a simple random sample is not an easy task. I should warn you that random doesn't mean haphazard. In other words, just manually grabbing things at random does not necessarily mean a random sample. The two classic ways of selecting a simple random sample is to use technology or something like drawing names out of a hat. I always find that kind of interesting that they call this a formal method of drawing names out of a hat. Doesn't sound very formal, but I know what they're getting at. All right, so that's kind of a review of the stuff that we talked about on Monday: a sample, a population, simple random sample, and oh, we also talked about sampling bias, which I believe have we already defined. Did we define sampling bias here? I thought that we did. It's supposed to be hiding somewhere. Oh yeah, we did. It's right there. I know we talked about that. All right, so in the next video, what I'm going to do is just touch on some of the specific examples of sampling bias and also specific examples of how you think your sample is trying to represent a population, but it might not be the population you think it is.